Everyone, this is another stop. I'm trying to explain a physics exercise here with the drawing. So let me start. So it says here like we have a boy pushed horizontally on a 10 kilogram wagon from rest, and it accelerates at 2.5 meter per second squared if a frictional force is 50 Newton. So the first equation is calculate the net force acting on the wagon. Alright, so I made this drawing. This is the person pushing on a wagon. So I used the pages for that. And the wagon is 10 kilograms, and there is a force of friction while acting opposite to motion with 50 Newton. And then the question, what is the net force acting on the wagon? Okay. For that, for the net force, we use Newton's second law of motion. The net force equal mass times acceleration. So we know here that the mass of the wagon is 10 kilogram and the acceleration is 2.5 meter per second squared. When we multiply these together, so we get the value of the net force, which is 25 newtons. So I put it here. This is the net force in red, 25 Newton, and this is the force in black that the guy or the boy is pushing with on the wagon. Okay, the other question is what force must the boy push on the wagon? Uh, okay, so we know now the net force. Then we can go ahead and say that the net force is usually a sum of all the forces, or all the forces in the positive direction minus all the forces in the negative direction. And we come here and then we um, take this direction, our positive direction. So all the forces in the positive direction. Okay, so the net force is 25. All the forces in the positive direction would be like the force he pushing with. Okay, minus all the forces in the negative direction minus the force of friction. When we do that, then we come to this. So 25 equal F push minus 50. You plus add 50 on both sides, and then after you do the calculation, so the guy has to push with a force of 75 Newton. It does make sense because if I take, so he's pushing here, he has to push here with a force that's equal 75 Newton. Let me see here. One moment. I don't want to lose the time here. Okay, with a force of 75 newtons. Okay, well, it does make sense because if you take this black arrow represented to 75 newtons, so first of all, he has to push with a force of 50 newton to overcome the frictional force, and then another 25 newton to push it ahead. So this is 75 newton as you see here. So it has to push first with a 50 newton to release this from the friction force, and then another 25 to make it move with 25 newtons. Okay, calculate the weight of the wagon. That's easy to do. You know the weight is usually equal m times g, and it's the force acting perpendicular to the surface of the earth directed toward the center of the earth. So the weight is usually the gravitational force equal m times g is also 9.8. I put it here somewhere. Yeah. So m times g. If you wanna consider the direction, then you have to put minus because the g usually is the acceleration due to gravity. It's an arrow that it is perpendicular to the surface, to the center, perpendicular to the surface of the earth, directed to the center of the earth. So I put here 980 newton, or if you want to consider the direction, this is minus 98. Okay, what is the value of the normal force? The normal force is usually, it is the force that is perpendicular to the surface of contact, and then opposite to weigh-in equal the weigh-in value if the surface is flat, if we consider in one direction, in one motion in one direction. So it is, so if the weight is minus 98, then the normal force is 98. Just opposite to it. Okay, perpendicular to the surface of contact. Okay, and then calculate the coefficient of kinetic friction. Let me see the coefficient of kinetic friction here. Well, let's assume that the frictional force is now, so he has to overcome the frictional force here. So that could be kinetic, could be static actually. Okay. If we consider the 50 as kinetic, like he just moved, he was about to move the wagon, just about to move it, and then we said that the kinetic frictional force equal coefficient of kinetic friction times the normal force, and then the kinetic, if this is the kinetic frictional force, then it is 50, and then the normal force from here we get it 98. Okay, and then we put everything by its value. We solve this, we divide both sides by 98, so it's 0.51. This is the coefficient of kinetic friction. Okay, calculate the velocity of the wagon after 10 seconds, and then for that we can use one of the kinematic equations for motion with constant acceleration. We can use the first equation for that. So we need the final velocity after 10 seconds. So we need the final velocity. He started with 0, and then the acceleration is 2.5, and the time is 10 seconds. And when we do the calculation, the velocity would be 25 meters per second after 10 seconds. So this is it. After 10 seconds, the velocity will be 25 meters per second. Okay, and then let me see. Calculate the distance traveled by the wagon after 10 seconds. Well, again, we need to pick up one of those equations to calculate the distance. And usually, if you want to pick up an equation, each equation has 4 variables. You need to have 3 at least, and you calculate the 4th. Well, in this case, anyone can do the job, because we have the initial velocity, the final velocity, we have the time, we have the acceleration. Okay, so any one of them can do the job. So if I pick the second equation, I will be applying this formula here. Initial velocity is 0, 25 velocity after 10 seconds. The final velocity is 25 after 10 seconds, and it's gonna give you x1 25. If you use the 4th equation, also you put everything by its value, you get to this. The 3rd equation is the same exact answer. Okay. All right. I want to mention something here. I would like to just give the free body diagram of all the forces acting on the wagon. No, let me tell you first that the distance traveled by the wagon after 10 seconds is 125 meters or so. And to explain, to just represent the displacement, if you want, you have to start from one point on that object to the same point of that object in the second position. So if you start from the beginning of the wagon here, you have to go all the way to the beginning of the wagon, and that will be 125 meters. Okay, so this is the full picture. This boy was pushing with 75 Newton. 50 of this went to release the wagon off the floor, and then the other 25 is to push it ahead, and then the acceleration was 2.5 meters. After 10 seconds, the speed of the wagon was 25 meters, and it was displaced by 125 meters. This one is the full body diagram of the wagon. I like it because it shows here that why is the net force 25, because the way and the normal force, they're opposite to each other and they cancel each other. They're the same value, opposite directions. And then along the x-axis here, you have plus 75 minus 50, so that gives you a net force of 25. So this and this is 0, and this gives 25. Okay, that's all.